Hi students, welcome back. In the last class we discussed about series combination of resistors. Today we are going to discuss about parallel combination of resistor. Okay, for this we want to consider three resistors R1, R2 and R3. And these three resistors which are connected like this, one resistor, okay, and the second one and the last resistor. Okay, three resistors are connected like this. This will form the parallel combination of resistor. Okay, this resistor is having resistance R1, this one is having resistance R2 and this one is having resistance R3. And these three resistors are connected to a voltage source V. Okay, now this circuit is a closed circuit. Therefore, current begins to flow through the circuit. Current begins to flow through the circuit. Okay. When current reaches here, what will happen to that current? In front of the current, there will be three pumps. Okay, so current begins to flow through this way and this way. Okay, if I1 be the current flowing through this path, I2 be the current flowing here and here it's equal to I3. Okay, that means the total current I or the current which is drawn from the cell which is divided into three, that is I1, I2 and I3. So we can write the total current I is equal to I1 plus I2 plus I3. Okay, total current I is equal to I1 plus I2 plus I3. Total current I is divided into 3. Okay, that varies with the values of resistance. The first one is current varies. Current varies with the resistance. Okay, now we want to check what about the voltage. What about the terminal of R1? Okay, this point and this point. Okay, if we represent these points as A and B. This point A and B. Okay, now we can take these points. These 2 points which are connected to this voltage source V. What about this point C and D? C and D is also connected to the same voltage source. What about E and F? E and F, this is also, these 2 points are also connected to the voltage source V. So we can say that if the voltage drop across R1 is V, then voltage drop across R2 is also equal to V, and then voltage drop across R3 is also equal to V. Because the terminals of R1, R2 and R3 are connected to the voltage source V. Okay, so we can say that in parallel combination, voltage remains constant. Voltage constant. Okay. Now, V is the applied voltage and that voltage which remains constant everywhere. Okay. Then voltage drop, according to Ohm's law, we can say that voltage drop across the resistor V is equal to I into R. So we can write what about the voltage drop here? I1 is the current which is flowing through the resistor R1. So voltage drop there is equal to I1 into R1. Okay. What about the voltage drop here? It's also equal to V. Then V is equal to I2 current which is flowing through the resistor R2. Then I2 into R2. I2 be the current and R2 is the resistance, then I2 into R2 is equal to V. Okay. Here what about the voltage drop? Voltage drop is V. Then that voltage drop V is equal to, what about its value? I3 be the current flowing through the resistor R3. Therefore, I3 into R3. Then we can write, what about I? From here, what about I? I is equal to V divided by R. Okay, I is equal to V by R. Then what about I1? From here we can write I1 is equal to V divided by R1. V divided by R1 plus what about I2? I2 is equal to V divided by R2. V divided by R2 plus what about I3? I3 is equal to V divided by R3. V divided by R3. Okay. V is common here, that is taken outside. V into 1 by R1 plus 1 by R2 plus 1 by R3. Okay, that is equal to V by R. V get cancelled. Therefore, we can write 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, this is the parallel combination of resistor. So we can write it as RP, P for parallel combination. So 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. From this equation, we can say that effective resistance is smaller than the smallest value in these three resistors. Okay, therefore what will happen here? This is third point, effective resistance decreases. Okay, then what are the points regarding the parallel combination? In parallel combination, current varies with resistance. Okay, according to the value of resistor, current varies. And which quantity remains constant? The voltage remains constant in parallel combination. And the third point is resistance, effective resistance decreases. Okay, and that value is smaller than the smallest value in these three resistors. Okay, for example, if R1 is equal to 1 ohm, R2 is equal to 2 ohm and R3 is equal to 3 ohm, then what about the effective resistance? Effective resistance is smaller than the smallest value here is equal to 1. Okay, and the effective resistance which is smaller than this 1 ohm. Okay, that's the meaning of effective resistance smaller than the smallest value. Okay, once again we want to write the equation for the parallel combination. 1 by R parallel is equal to 1 by R parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. What about R1 is equal to R2 is equal to R3 is equal to R? If all these three resistors are having same resistance, what will happen there? 1 by R parallel is equal to 1 by R plus 1 by R plus 1 by R. What about its value? 1 by R plus 1 by R plus 1 by R is equal to 3 by R. So 1 by RP is equal to 3 by R. Therefore, RP is equal to, okay, 1 by RP is the reciprocal of RP. Okay, then RP is equal to 3 R. Then RP is equal to R divided by 3. Okay, by effective resistance here is equal to R by 3. If there are 4 resistors, then 1 by R plus 1 by R plus 1 by R plus 1 by R. What about that? 4 by R. Then what about the effective resistance? R by 4. Okay, if there are 5 resistors of equal resistance, then R divided by 5. If there are n resistors, then we can write it as R by n. Okay. If there are 4 resistors, what about its value? 1 by R plus 1 by R plus 1 by R plus 1 by R. That is 4 by R. 4 by R is equal to 1 by RP. Okay. Then RP is equal to R divided by 4. If there are 5 resistors, then what about RP? RP is equal to R divided by 5. If there are 10 resistors, then R divided by 10. If there are n resistors, what about RP? RP is equal to n resistors. Then RP is equal to R divided by n. This equation is also very important. Okay, in parallel combination, effective resistance is equal to R divided by n. Okay. Now we can do certain problems related to this parallel combination of resistors. Okay. Our question is, 3 resistors are there and these 3 resistors are connected in parallel manner to a voltage source 24 volt. Now we want to find out the current drawn from the cell. What about I? The second question is, what about the current flowing through each resistor? That is I1, I2 and I3. Okay, what about I1, I2 and I3? Then what about the effective resistance of the circuit? What about the effective resistance of the circuit? These are the 3 questions coming from this portion. Okay. First of all, we want to find out what about the effective resistance of the circuit RP. Okay, what's this equation? 1 by RP is equal to, in parallel combination, 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That's equal to, R1 is 10, that is 1 by 10 plus 1 by 4 and the third resistor is 8, that is 1 by 8. 1 by RP is equal to like this. Okay. Then how can we do this problem? Okay. What about the common denominator? We can take it as 80. Okay. Then 1 by 10. How many times 10 goes to 80? 8. Plus, what about here? Here it's equal to 20. Plus, here 1 by 8. It's equal to 10. Then 28, 38. Okay. Then 1 by RP is equal to 38 divided by 80. Okay, therefore RP is equal to 80 divided by 38. Now we can cancel, it's equal to 40 divided by 90. It is approximately equal to 2.11 something. Okay. RP is equal to 2.11 ohm or it's equal to 40 by 19 ohm. Okay, that's the effective resistance of this circuit. Okay. So we can write RP is equal to 40 by 19. 40 by 19 or it's equal to 2.11. Okay. Now we want to find out the value of I1. According to Ohm's law, we can write it as I is equal to V divided by R. Here we take RP. V equal to, what about V? V is equal to 24 volt. Okay, 24 volt. 24 divided by, what about the effective resistance in parallel combination? 40 divided by 19. 40 divided by 19. When 19 comes to the top, it becomes equal to 24 into 19. Okay. We can cancel this. 20. Here it's equal to 12. Once again, 6 here. 6 into 19 divided by 10. That's equal to, what about 19 into 6? 19 into 6. 19 into 6. Remainder 5. 6 plus 5 is equal to 11. Okay, that's equal to 114 divided by 10. That's equal to 11.4. Okay, that's that much ampere current which is drawn from the cell. That is equal to 11.4 ampere. Okay, now we want to find out what about the current I1, I2 and I3. We know that the voltage applied in parallel combination is same. It's equal to 24. Okay, that is the applied voltage. So V is known. Then V is equal to 24. What about the resistance here? Resistance R is equal to, R1 is equal to 10 ohm. Then what about I1? I1 is equal to, according to Ohm's law, we can write V by R1. V is equal to 24. 24 divided by 10. That is equal to 2.4. This much ampere. Then what about I2? I2 is equal to 24 is the voltage which is applied and 4 ohm is the resistance here. Then I2 is equal to V divided by R2. That's equal to 24 divided by 4. 24 by 4 is equal to 6. 6 ampere. Then what about I3? I3 is equal to voltage divided by resistance, that is R3. Voltage is equal to 24. 24 divided by, what about R3? 8. It's equal to 3 ampere. Okay. I1, I2 and I3 are known. Okay. Then what about total I? Total I is equal to 11.4. Okay. When we add these three values, 2.4 plus 6 plus 3. What about its value? 6 plus 3 is equal to 9. 9 plus 2.4 is equal to 11.4. That is the voltage drawn from the cell. Okay. So we can find out the current drawn from the cell by this method also. First of all, find out the values of I1, I2 and I3. Then add these three values. Then we get the total current I that drawn from the cell. Okay. This is simple than that of the first method. In first method, first of all find out the total resistance. Total resistance is equal to 1 by Rp is equal to 1 by R1 plus 1 by R2, 1 by R3, like that. Then by using the equation I is equal to V by Rp, we can find out this value. Okay. In the second method, first find out I1, I2 and I3. Okay. Then add these three values. Then we get the current drawn from the cell. You can use any method to find out the answer. I think this topic is clear for you. If you like this video, please subscribe and share to friends. Okay, thank you.